Alright, so this is the video for assignment number 2 in Unit 9, which is on arithmetic, which is on sequences and series. However, specifically, assignment number 2 is on arithmetic sequences. Some vocabulary and terminology to get going here. First of all, an arithmetic sequence is something that has what we call a common difference. A common difference, we're going to denote that as D. But a common difference is something like with this particular sequence where the common difference is 3. The common difference is what we add to each term to get the previous term. So 13 plus 3 is 16, 16 plus 3 is 19, and if I keep adding 3 each time, that's what makes it an arithmetic sequence. Arithmetic sequences only are those sequences where you add or subtract a common number from one term to get to the next term. If we're multiplying or using any other operation other than adding or subtracting, then it would not be an arithmetic sequence. Okay, so it has to have a common difference, which we're going to denote as D. There's two formulas that we're going to use throughout this that I would like for us to just talk about and introduce right now that we're going to use in some of these examples that will be following in this video. And the first one is a specific recursive formula for arithmetic sequences. Every recursive formula will be in this form. We're going to have each term. Remember, a recursive formula is denoted as a formula that is based on the previous term. So to find a sub n, which is any term number, we're going to start with the previous term. And if it's an example like this one, where we go from 13 to 16 to 19, we always take the previous term and add 3. Generally, though, we're going to call that the difference, since the common difference is D. And a recursive formula will generally be in that format. This should be something in your notes. We're going to use it often, not only in this video, but also in future assignments and lessons as well. An explicit formula, in general, will look something like this. To find a sub n, again, the nth term, we are always going to start off with the first term, okay, 13, and we're going to add the common difference n minus 1 number of times. So for example, in this particular example, the first term is 13. If we start with the second term is 16, but we started with 13 and we added 3 once. To get the third term, which is 19, we started with 13, that's the first term, and we add the common difference, which is 3, twice. To get to the fourth term, we started with 13, which is the first term, and we added 3 times. So it's always 1 less than actually the term number, and that's why it's n minus 1. This is the general format that we're going to use when we write explicit formulas to describe an arithmetic sequence. One more formula, and that is when we talk about an arithmetic mean. The mean is simply the average. An arithmetic mean is the number between two numbers. So for example, if I want to find the number between 16 and 22, I'm just going to take the arithmetic mean, which is what you would commonly refer to as the average. To get that, we're just going to take the two terms. I'm just going to call them A and B and divide by 2. And that's going to be the arithmetic mean. So these three formulas are three formulas that we're going to use throughout this lesson, and we're going to build upon this in each assignment that we go on from this point. So let's take a look specifically at example number 1. What we're going to do first is write a recursive formula for this. The recursive formula is going to be a sub n equals the first term, or to get a sub n, we're always going to take the previous term, which is a sub n minus 1, and we're going to add 3. Because 3, oops, let me get to the point where you can actually see this. Because 3 is the common difference. This equation right here is a recursive formula for this particular sequence. An explicit formula is going to be a sub n equals our first term, which is 13. And we're going to add the common difference, which in this case is 3. But we're going to add 3 not n times, but n minus 1 number of times. So an example of this, of something with this, would be, can we find the 50th term? Can we find the 50th term in this sequence? Which formula would be more conducive to this? It's either going to be the recursive formula or the explicit formula. But if you remember that in order to use the recursive formula, we'd have to know the 49th term. And then to get the 49th term, we'd have to know the 48th term. So with what we're going to do, without a spreadsheet to go through this, we're going to use the explicit formula here. And if we want to find the 50th term, that means that n is going to be 50. So the question would be, can we find a of 50, or a sub 50, which is the 50th term? Well, to do that, it's going to be 13 plus 3, and then 50 minus 1 number of times. That's 13 plus 3 times 49. And 13 plus 3 times 49, I believe, is 160. Which means the 50th term of this sequence, if we continued on, this is the 5th term, if we continued on to the 50th term would be 160. Let's look at a few more examples of this type of thing, and we're going to start with example number 2, and again, you should be putting these in your notes. One of the things that's going to be really important for us to be able to do is to write both a recursive formula and an explicit formula for these arithmetic sequences. So if you want to try this first on your own, you can pause the video, give it a shot on your own, and then restart the video and see how close you were. In this particular example, I'm adding 2.5 each time. Okay, so that is our common difference. So the recursive formula is going to look something like this. Remember, we start, a sub n is always going to be the previous term. So we start with the previous term before a sub n, and we're just going to add 2.5. The explicit formula, to find a sub n, we always start with the first term, which is 7, and we add the common difference, which in this case is 2.5, but we're going to add 2.5 n minus 1 number of times. And again, if we want to find the 50th term, so we would go find a sub 50. That means, can we figure out what the 50th term would be? It would simply be 7 plus 2.5, 50 minus 1 number of times. And 50 minus 1 is 49, times 2.5 plus 7. If I did my math right before we started this video, that is 129.5. So the 50th term, if we went on, the 50th term here would be 129.5. Okay, let's do example number 3, but it's going to be a little bit different of a twist on here as far as the question that I asked you. But let's first start with both the recursive formula and the explicit formula. Again, if you want to pause the video and just try this first on your own, probably be a good idea. Recursive formula is going to be a sub n equals the previous term, which is a sub n minus 1. But if you notice on this example, we subtract 6 each time. So the common difference is negative 6. So we're going to start with the previous term and subtract 6. This is an example of the recursive formula. We're going to use the recursive formula more in future lessons. The explicit formula would be a sub n equals, we're going to start with the first term, which is 15. We're going to add the common difference, which in this case is negative 6. So you can say we're adding a negative 6, or you can just say we're subtracting 6, n minus 1 number of times. And again, the reason for that, here's our first term. To get our second term, we start with 15 and we subtract 6 once. To get our third term, we start with 15 and we subtract 6 twice, and so on. So it's always subtracting 6, not n times, but n minus 1 number of times. So here's a question. Let's say that we have a certain term number that happens to be negative 255. In other words, if we keep going here, we're eventually going to get negative 255. What term is that? 3 is the third term, negative 3 is the fourth term, negative 9 is the fifth term. What term would negative 255 be? Well, if a sub n is negative 255, we're going to use our explicit formula that's going to look something like this. Negative 255, we got negative 255 if we use this formula by taking 15 minus 6, n minus 1 number of times. So we're simply going to solve this equation for n. Several ways we can do this. We could subtract 15 from both sides. Negative 255 minus 15 is negative 270. That equals negative 6 times n minus 1. I could distribute the negative 6, or I could simply divide both sides by negative 6. So n minus 1 is equal to negative 270 divided by 6. So I'm going to have to use my calculator here, which is 45. Then if I add 1 to both sides, n is equal to 46. So that means that negative 255 is the 46th term of that sequence. And we use the explicit formula in order to determine that. So let's look at two more examples real quickly with a different twist on each one of them. The first one is we want to find the mean, the arithmetic mean between these two numbers. Suppose this is an arithmetic sequence. There might be numbers prior to this. There might be numbers after this. But we want to find the number between, the term that's between negative 52 and negative 128. Well, that's the arithmetic mean. And to find the arithmetic mean, again, the formula was a plus b over 2. We're just simply going to add these two numbers together. Negative 52 plus a negative 128, that's a 1 there, and divided by 2. So negative 52 and a negative 128 divided by 2 is equal to negative 90. And so the arithmetic mean, which would go right here, is simply negative 90. So what about one like number 5? And again, these should be in your notes. What if we have numbers prior to 27 or after 71? This is somewhere in our sequence, but we want to find the 3 numbers that are between 27 and 71. Well, in order to do this, we're first going to find the number that's directly between them. So 2 after 27, but 2 prior to 71 would be the arithmetic mean of those two numbers. So we can start by taking 27 plus 71 divided by 2. That is equal to 49. So that means this number, the arithmetic mean of 27 and 71 is 49. Once we get that number, then we can use it to find the other two numbers. For example, the number that goes here is the arithmetic mean between 27 and 49. So I can take 27 plus 49 over 2. 27 plus 49 over 2 is 38. So this number is 38. And I can do the same thing with 49 and 71. 49 plus 71 divided by 2 is 60, which means this number here would be 60. The common difference would be 11, because 27 plus 11 is 38. 38 plus 11 is 49. 49 plus 11 is 60. 60 plus 11 is 71. So it is an arithmetic sequence because it does have a common difference. Keep in mind, on your homework assignment, you might have, I wasn't planning on doing this, but you might have an example that's something like this. Maybe it starts off with 3, and then 6, and then 12, and then 24. This is not an arithmetic sequence because it doesn't have a common difference. Here we're adding 3, but here we're adding 6. And because I'm not adding the same thing each time, it is not a common difference. So hopefully you took notes on this. Hopefully this was pretty self-explanatory. You can rewind the video to watch anything that you might be confused on, and we will talk to you later.